Number 5, given two strings x and y, find the length of the longest common substring. So what we're looking for in this problem, we'll have a string x and a string y, and we're going to be looking for the longest common substring, which is, if we see in this example, a common substring here would be A, B, C, D here and here, because you can see they both share the same character and length. And we also have one here at XYZ, and in the front here, this one has 3 characters and this one has 4, so the output that we would have for this example would be 4, since it's the longer of the two. Okay, so the way that we're going to solve this is using dynamic programming. And so I have my grid out, and I'll have S1 along the columns and S2 along the rows. And we'll basically be going like one index at a time. So starting with X for string 2, we'll be taking that. And then we'll be looking as we bring it in each index at S1 and comparing. So when we have A, we'll have 0 as the LCS, and then B, also 0. Bring in C, there's no match. D, there's no match. Then when we bring in X, we'll have 1, since we have X and X. And then Y, since we don't have anything else to compare with, it'll still be 1. And then going down and say when we have XY from string 2, we bring in A, we have 0. B, we have 0. C is 0. D is 0. We bring in the X, we'll have 1, since we have X here and X here. And then when we bring in the Y, we'll have 2. And so then we'll just, as we go on, we'll have all the combinations possible, and then we'll be able to get the largest number that comes out of this. So I have 2 for loops, so that we'll be going down each column, or each row, column by column. And then to start this off, if I equals 0 or j equals 0, so basically this first row and this first column, and I'm just going to write this out, this is all going to be 0. And this is going to kind of just be set up as sort of like a control, because we're going to be doing some comparison operations in order to get our value at each box. And so I basically just did this first one at I at 0, so I'll go ahead and bring down, and then we're going to be comparing so we'll be looking when we have S2 character at I minus 1 or S1 at j at 1. So this first one, when j is at 0, it's going to be 0 because j equals 0. But then when we get to j equals 1, we'll be looking to X and comparing it to A. And if it doesn't match, then we are going to be looking at the value at I minus 1. So that's 0 at j. So that's this one here. And then we'll be comparing that to the one at I and j minus 1. So that would be this box here for this one. So we'll be comparing, and then whatever the largest value is, we'll put it into here. And so we'll continue down. X comparing to B is not a match, so we'll be doing this again, and all we have is 0. X to C is not a match, so again we just get 0. X and D. Alright, so now we do have a match when we get to X comparing to X. And so now we're here. If these two match, then this, what we put in here, is what we take I minus 1, which is 4, and then J minus 1 is 0, so this like adjacent box basically will take the value from here and add 1 to it. So since we have a 0, we'll add 1. And again, that just kind of represents what we have here. We've gone and compared it along until we got to X, and so now we have 1. So we'll keep going. X compared to Y, we don't have a match, so now I have 1 versus 0. 1 is the largest one, so we'll put 1 in there. And then lastly, X compared to Z, we'll just do this comparison, and then we get 1. And now we move I, and then we start all over again. So this will be 0, and then this box will be when we are comparing Y to A. And so Y compared to A is not a match, so then 0 is the largest that we get out of that. Y and B is not a match, so we get 0 again. Y and C, nope, 0. Y to D, no match. Again, all we have is 0. Y at X, we don't have a match, but we have 1 here. Beats out 0, so we get 1. And that makes sense because if we have X and Y, if we compared it up to X, then we would have 1 there. Now Y compared to Y, we get a match, so we take this adjacent square, add 1 to it, and then we get 2. And then Y to Z is not a match, so 2 versus 1, we get 2 is larger. Alright, so now we get I equals 3, so 3 minus 1 is 2, so now we're comparing Z, and then we start at 0 there, so Z at A, it's not a match, so 0 here. C and B is not a match, so we get 0 versus 0 is 0. Z and C, 0. C and D, we get 0. C and X, nope. We get 0 versus 1, we get 1. Then Z versus Y, so we'll do this again. 1 versus 2, we get 2. Then Z against C, now we have a match, so we take this 2, we add 1 to it, and then we get 3. Alright, now I equals 4, so we're doing A here. And then this will be A versus A, so we get a match there. And so add A to 1. And since I can just see from here on out there's no more A's, so I'm just going to quickly go ahead and do this comparison. So 1 and 0, we get 1. 1 and 0 is 1. 1 and 1 is 1. 1 and 2 is 2. And then 2 versus 3. And again, just to double check, if we had X, Y, Z, A, when we, in the very beginning when we bring in A in, we're already going to have 1 just starting off the bat, and then B, C, D, it's still going to be 1, and then X, again, we'll have another subset, but then that will still equal 1. And then once we bring in Y, then we get 2 and Z. And then we have 3, and that kind of represents here. As you can see, we have 1 all throughout until we bring in that Y, and then we get 2 becomes the LCS, and then 3. Now we'll just continue on. I equals 5, so now we'll be looking at B. All right, so B and A. Oh yeah, B and A doesn't match, so 0 versus 1 is 1. Now B versus B, or V matches B, so we take this 1 and we add 1 to it, we get 2. And again, no more B's are left, so I can just compare for the rest. 2 versus 1 is 2. 2 versus 2 is 2. And then 2 against 3 is 3. Now I equals 6. So we're looking at C. C and A doesn't match. So we get 0 versus 1 is 1. C and B does not match. So we do 1 versus 2 is 2. C and C does match. So we'll take this 2, add 1 to it, and then we get 3. And then yeah, no more C's for the rest. So 3 versus 2 is 3. 3 versus 2 is 3. 3 versus 2 is 3. And then 3 versus 3 is 3. Alright, now I equals 7. So we have the last one with D. Alright, again, D versus A. Not a match, so 0 versus 1 is 1. D and B is not a match, so 1 versus 2 is 2. D and C is not a match, so 2 versus 3 is 3. D and D are matched, so we take this 3 and we add 1 to it. And then X, no, so 4 versus 3 is 4. 4 versus 3 is 4. And we have 4. And then that lines up because then we have A, B, C, D here, and then that equals 4. This other substring is 3, so 4 is our longest common substring. And then the time complexity of this is O of M times M, since we have like a matrix that we're going along, and then we also have a space complexity of M times N, because that also equals out.